All right. If you thought Khan Academy was bad at drawing, wait until you see mine. This is my right cylinder. There we go. Okay, so it fits the location. It has a height of 61 inches, so that's this part going between the two circular bases. That's the height. And a diameter of 20 inches, so all the way across. That's the diameter. Um, how much water can this water tank hold? What's the volume? So to find the volume of a right cylinder, so the volume is a three-dimensional measurement. Dimensions means one dimension means you can either go left and right, one direction. Two dimensions, you can go left, right, up and down, two directions. Three dimensions means you can go left, right, up and down, forwards and backwards. Okay, so volume is a three-dimensional measurement, and it's the base times the height. So if we find out the two-dimensional area of this base and then multiply by the height, we've got the volume. So the area of that base is pi r squared because it's the area of a circle. Okay. And then that's the base. We need to multiply it by the height. So we're going to multiply, I'll say by h for a general formula. That's the volume of a right cylinder. And so I'm going to plug in 10 in for r, and then we've got 61 for the height. And that's the pi symbol. So in your calculator, there's usually a pi symbol. And look, 10 squared means 10 times 10, right? So you can do this, and you're not breaking any math rules by doing pi times 10 times 10 times 61. And so remember our units here. These are all inches. It's inches times inches times inches. So you got inches cubed. So this is roughly 19,163.7 inches cubed. Okay. That's the volume of this right cylinder. So we don't usually talk about things in cubed inches in terms of dimensions, right? We usually talk about things in terms of gallons. So here's our conversion factor. 1 gallon is 231 cubed inches. So what we'll want to do is we'll want to multiply this by a conversion factor so that we can make the inches units, the inches cubed units, cross cancel to leave us with the gallons, the things that we wanted. So that means we're going to want inches in the denominator. So this one's all set up because an equivalent way of writing this is 231 cubed inches over 1 gallon. That's fine too, but we want this form so that inches cubed can cross cancel. So we'll multiply this by 1 gallon over 231 cubed inches. Okay? So the cubed inches units cross cancel because one's in the top of a fraction, one's in the bottom. So you're going to get 19,163.7 in the top, and in the bottom you get 231 gallons. And with our calculator, I hear you making fun of my handwriting. It's a 82.96, roughly 82.96 gallons. Okay, and that's it for question 1. Second question is the same type of thing. What's the volume of the pool? So we'll want to do pi r squared again. Let's see. This is real too. I was looking up one of the small pools, and for some reason they gave us 160 centimeters and 12 inches. They mixed the units. I have no idea why, but I had to make the conversion to compare it to another pool. So there you go. Don't tell me this isn't real world. So it's 160 centimeters in diameter, so that means it's 80 across because the diameter is all the way across. Sorry, not 80 across, it's 80 for the radius. The radius is halfway across from a point to the center, from point on the edge to the center. So when you have the diameter, just divide it by 2 to find your radius. So that's pi r squared. Oops, but if we're going to use our conversion factor over here, if we use the same one we used in question 1, we want things in terms of inches. So instead of 160 centimeters, let's convert that to inches. I'll multiply it by this conversion factor. You can say 1 inch is 2.54 centimeters, or it's perfectly fine to say 2.54 centimeters is 1 inch, right? So which one do we want? We want this one. That way our centimeters can cross cancel. One's in the top, one's in the bottom of a fraction. So I'm going to multiply this by 1 inch that looks like Lin. There we go. 2.54 centimeters. That way these cross cancel. And then we've got 160 over 2.54 inches. And so with our calculator, 160 divided by 2.54, that's about 63 inches. Okay, remember 160 was the diameter though, so we need to cut this in half. So that should be 63 divided by 2. So this is 31.5 for a radius. So square that and then multiply by the height. And this is inches cubed. Because this is inches. Inches times itself makes inches squared. And then 12 was also in inches, so we get inches to the third power. Okay, and then going left to right with my calculator. Here's pi times 31.5 times 31.5 times 12. So here's our answer in cubed inches. 406.9 cubed inches. And then we'll do just what I did in the last problem. I'll leave that for you to convert this from cubed inches to gallons. Okay, just like we did in the last problem. You want to take this and multiply it by this conversion factor. Okay, we got a cylindrical punching bag, and this problem comes from a former student of mine that asked me if I could help them find out how many bags they should buy. Okay, so diameter is 14 inches, so we got 7 inches for a radius, and the height is 42 inches. So one bag of punching bag filler will fill 14 liters. Okay, so it looks like we need to convert from cubed inches to liters. And you can always Google search these conversion factors. In fact, if you type it in Google, it'll automatically calculate from one unit to the other. The thing that Google and other smart computer programs has a hard time with is actually math word problems. For some reason, it gets the steps right, like ChatGPT can get the steps right, and then they just slip in some random numbers in there, or they mix up one of the numbers, or they make a mistake in the calculation. So that part you need to know how to handle. Okay, so the volume is area of the base, which is a circle, pi r squared, times h, and that's inches cubed. I won't give you another spiel on why it's cubed. So let's find the volume that we need to fill. This is the punching bag. Like once you're done doing one of these math lessons, you might want to go hit a punching bag. I don't know, it's so boring or something. This is cubed inches. Okay, and so we need to convert that to liters. That way we can compare the punching bag filler, which gives us 14 liters, and how much we need over here with cubed inches. So here's a conversion factor. 1 liter is 61.02 cubic inches. So I could say 1 liter is 61.02 cubic inches, or I could say 61.02 cubic inches is 1 liter. The one I want is this one over here because I want inches in the denominator. That way the cubed inches can cross cancel. Okay? So I'm going to multiply this by 1 liter over 61.02 cubed, oops, why did I write an M? Cubed inches. So the cubed inches cross cancel. And so you're going to have 6465.4 liters over 61.02. So I still got that number in. So we got, here, let's round up. We need 106 liters. All we've done so far is we said, hey, this is the volume in cubic inches. This is the volume in liters. We need 106 liters. One bag covers 14 liters. So to find out how many bags we need, that's a division problem. 106 liters split into 14 liter bags. How many bags are we going to make? How many groups are we going to make? That's 7.57 bags. So we'll just round up to 8 because we'd rather have more than less. So for this problem, we need 8 bags of filler.